Accelerated Chem, sorry I can't be in class today, but I thought I'd do a little video for you to help you predict the products for reactions so you can work on pages 31 through 34. So let's get started with the decomposition reaction. We know that in decomposition reactions, we have a compound that breaks apart into smaller pieces. So a compound like AB, which would break apart into A plus B. So let's say we have something like NaCl. We know it's going to break apart into its components, so we can even draw a little dot right down the middle. So once it breaks up, we can have sodium plus chlorine. Now remember your Hofbrinkels, chlorine is a Hofbrinkel, so that means it's a diatomic atom, and it does not exist on its own. It has to have a twin with it. And once we make sure we have our diatomics, we can balance the reaction. So I have 2 Cl's on that side and only 1 on this side, so I need to put a 2 in front of NaCl. Now I have 2 sodiums and only 1 sodium on this side, so again, I need a coefficient of 2. Now, let's do a synthesis reaction. Exactly the opposite as a decomposition reaction. So let's say we had, first of all, here's the general formula for a synthesis reaction. You have the 2 pieces and then they come together. So let's say we had sodium plus sulfur. And what I like to do is look at the charges for sodium and sulfur and see what their ionic charges are. So when they come together, I know what subscripts to write. So the charge of sodium is +1 and the charge of sulfide is -2. So I know in order to have a neutral compound, I must have 2 sodiums for every sulfide ion. Now that this compound has a balanced charge, I can go ahead and balance my entire equation. Well, I have 2 sodiums on this side and only 1 on this side, so I'll put a 2 in front of my sodium here. Alright, so those are the first 2 kinds, decomposition and synthesis. Let's move on to a single displacement. Well, an example of single displacement could be F2. The general formula for a synthesis reaction is AB plus C yields CB plus A. Now remember, this is the example that we did yesterday where there's a couple dancing at homecoming and then somebody standing off on their own, and they come in and they butt in the dance and they switch partners so somebody else is lonely this time. So one example would be F2 plus KCl. And before I do anything, again, I'm going to write the charges in. Why do I have F2 here? Well, fluorine is a Hofbrinkel. And I know the charge of a fluorine ion is -1. The charge of potassium is +1. And the charge of chlorine is -1. Now, could I have fluorine and chlorine come together? No way, because they're the same charge. But potassium and fluorine would definitely be attracted to each other. So I can go ahead and write that as a product. And then also write in Cl. But remember, chlorine is also a Hofbrinkel, so it does not exist on its own. It's a diatomic element. So I have to put in the 2 there. Is my equation balanced? It is not. I've got 2 chlorines on this side and only 1 on this side, so I'll put a 2 in front here. And I've got 2 fluorines here and only 1 here, so I'll put a 2 in front there, and now I have 2 potassiums on both sides. Good to go. Now there's only a slight difference when it comes to the double displacement. Think of this as 2 couples that are switching partners. So it would be AB plus CD yields CB plus AD. Again, it's going to be really important to look at those charges when you're doing these reactions. So let's do an example. Let's say I had iron chloride, FeCl3, plus NaOH, sodium hydroxide. I'm going to go through and write in all my charges. So I'll use a different color this time just because there's a lot to look at. I know chlorine is -1. And so if I have 3 -1 charges, the charge of this iron must be +3. Sometimes it can be hard to know what the iron charge is because it can have multiple charges. So that's why you have to look at the thing that it's attached to. The charge of sodium is +1, and the charge of hydroxide is -1. So when I go through with my reaction, I need to make sure I have positive and negative things coming together because opposites attract and likes repel. So I can't put chlorine and hydroxide together because they're both negative. So that means that iron and hydroxide must go together. So I have iron, hydroxide, and since the charge of iron is +3 and hydroxide is -1, I must have 3 hydroxide groups. And then I can also put NaCl together. Now, don't forget to balance. So I've got 3 chlorines here. That means I'll need to put a 3 there. And that also means now I have 3 sodiums, so I'll have to put a 3 in front of sodium hydroxide. And I think I'm balanced. 1 iron, 3 chlorines, 3 chlorines, 3 sodiums, and 3 hydroxides, and 3 hydroxides. All right, there's only one more kind of reaction, and that's a combustion reaction. The combustion reaction is involved with a hydrocarbon. It always reacts with oxygen gas and yields carbon dioxide and water. So if I pick any hydrocarbon, let's say C2H6, it must react with oxygen, and it must yield carbon dioxide and water. So this one's really easy to predict the products because the products are always CO2 and H2O. This one's a little bit tricky though when it comes to balancing. So let's say I wanted to balance my hydrogens first. I would put a 3 in front of this H2O. And then I could balance my carbons and I would put a 2 in front of the CO2. But that puts me in a really dicey spot because I have 4 oxygens and 3 oxygens here, so that's a total of 7. Is there any way for me to get this O2 to 7? I can't multiply it by anything that's a whole number, so instead what I'm going to do is double everything that I have written down so far. So that becomes a 4, that becomes a 6, and in front of the C2H6 will become a 2. Let's see if this solves my oxygen problem. I've got 8 oxygens here, and another 6 here. That makes 14. Can I get O2 to be 14? Yeah, all I have to do is multiply by 7. And now I'm balanced. Hopefully this video helps you to start predicting the products in your packet on pages 31 through 34. Otherwise, you can consult your textbook or look on the internet to see if you can find any resources, or just look back at pages or target 5, and use those particulate diagrams to help you. I'll see you tomorrow.